The first thing I'm going to do is I'm going to look at this and I'm going to say, I really don't want to deal with a radical. I would rather deal with an exponent. So I'm going to rewrite it. Square root of x is the same thing as x to the 1/2. The next thing I'm going to do is I'm going to remind myself what that limit definition of the derivative is. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. All that means is I'm going to go back to my original function, my x to the 1/2, and anywhere I see x, I'm going to replace it with x plus h. And I still have that limit as h approaches 0. And now instead of x to the 1/2, I have x plus h because I replaced that x with x plus h. That whole quantity is to the 1/2 power, and then I subtract f of x, which is x to the 1/2, and I divide by h. If I were to directly evaluate this limit right now at this point and replace h with 0, I'd end up getting x to the 1/2 minus x to the 1/2 over 0, which would be 0 over 0, which is an indeterminate form. So what that basically means is I don't know what this is going to equal. I need to do something else to it. I need to write it in a different form and try and evaluate it that way. I'm immediately noticing that 1/2 means I have square roots, right? That's another way to think about it. What I can do is I can multiply by the conjugate. And what I mean by that is I'm going to multiply this numerator basically by itself. The only difference is going to be, instead of writing a minus like I have in the numerator, I'm going to change that and I'm going to change it to a plus sign. So I'm going to add that x to the 1/2. If I multiply the numerator by that, I also need to multiply the denominator by that. This quantity is just 1, so I'm just multiplying that original equation by 1. So I'm not changing the value, I'm just changing the form and how it looks. Now what I want to do is I want to multiply that numerator through and I want to see what it looks like. I want to combine like terms and simplify it. X plus h to the 1/2 times, well, it's going to be times itself. I have x plus h quantity to the 1/2. So when I do that, when I multiply something by itself, I'm in other words squaring it. Now I'm going to keep going. I'm going to take this and I'm going to multiply it by this, x plus h to the 1/2 times x to the 1/2. And then I get minus x to the 1/2 times x plus h quantity to the 1/2. And then my final term in this is going to be those x to the 1/2 minus x to the 1/2. Once again, I'm multiplying it by itself, so I'm in other words squaring it. I still have this whole thing over h, x plus h to the 1/2 plus x to the 1/2. And once again, I'm not going to multiply that through. It's already factored, so I'm going to leave it just like it is in that denominator. What I am going to do is I'm going to notice what happened to my numerator here. The first term, I have the quantity x plus h to the 1/2, and then I'm squaring it. Well, if you'll remember our rules of exponents, if I take an exponent and I raise it to another exponent, what I need to do is I need to multiply those. So I have x plus h, and then I have 1/2 times 2. Well, that's just 1, so I can leave it. I don't even need to put the 1 there. Let's look at these middle terms. These terms are the exact same. They're just in a different order. And if you'll notice, one is addition, one is subtraction. So these are going to add to 0. And then the next thing, the last thing I have in the numerator is this x to the 1/2 squared. Once again, I have a power and I'm raising it to another power. So I'm going to multiply those. 1/2 times 2 is just 1. So I have minus x. And then that is all over h times that quantity. Let's look and see what I've done. Let's look in that numerator. I can go ahead and I can drop these parentheses because they're not doing anything at this point for me. So what I have is I have x minus x. That's going to go to 0, and I'm left with h in the numerator, and then I'm just left with my denominator. And this is why I left the denominator the way it was and I didn't multiply that h through. It's already factored. So one of my factors is h in the denominator, and then I have an h in the numerator. H divided by h is just 1, so those will cancel out. So what I end up with is the limit as h approaches 0 of 1 over, and then I have the quantity x plus h to the 1/2 plus x to the 1/2. Now I can go ahead and I can evaluate this. I can plug in 0 for h and see what happens. I have 1 over, well, x plus 0 is just x raised to the 1/2 plus x to the 1/2. So I get 1 over 2x to the 1/2. I can write this in a few different ways. I could say 2x to the negative 1/2, and that would be fine for my answer. You can change that back into a radical, and we could say 1 over 2 to the square root of x, and then I'd have to rationalize my denominator. And I'd get square root of x over 2x, and that could be my answer.